Hello and welcome. In this third and final part in the series on building a weather station with a Raspberry Pi and Python, I'll be adding a database to the program to allow for the readings to be stored in a structured way. Following that, I'll be putting a simple web server together that will show the last 10 records from the database and include an option to download all the readings in the database to a CSV file. If you would like a copy of the source code, there is a link in the description to a GitHub repo for it. As always, if you get value from this video, please give it a thumbs up and click the subscribe button to get future content. With that said, let's get started. First up, I'm going to install an additional package called SQLAlchemy. If you haven't used it before, it's a library that allows Python to interact with various SQL databases such as SQLite, MySQL, and Postgres. To install it, you simply have to use the pip package manager again. Pip install SQLAlchemy. Okay, now that that's installed, I'm going to delete the requirements file. I'm just going to recreate it. As you see, SQLAlchemy is now in the requirements file, so I'm going to close that in the screen. And with that taken care of, let's move on to adding a database to the program. Okay, so the first we need to start doing is adding some files as a new module for the database. So I'm just going to expand the modules folder, and I'm going to create a new folder called database. And then within that folder, I'm going to create a number of files. First, __.py file, just to recognize that folder as a package. And then I'm going to create 3 additional files. First one will be crud.py. Now I'll explain what each of these does as we go. Next is engine.py. And lastly, models.py. So I'm just going to close these all down. I'm just going to run them one at a time. So the first file I'm going to use is engine.py. Drop some code into that. So a quick overview of what this code does. First, we're going to import the modules needed for this file. That pretty much is SQLAlchemy and the OS library. Next, we're going to create a path for where the database file will be stored, which will be 2 levels up from where the engine file is. So it'll basically sit in the same locations where main.py is. After that, we're going to create an engine that uses the database path and the database file name. So in this case, we're just going to call it database.db. Then we're going to create a session that uses the engine. And lastly, create a base class that allows for the program to interact with the database. So I'm just going to close that file down after I save it, of course. Next up, I'm going to open the models.py file. And I'm just going to dump some code into that as well. I'll go over that. The purpose of this file is to define a table that will be created in the database so that readings from the sensor can be stored and read back from. So we've got our imports at the top, and then we've got a class that we're making called reading. Now, within this, what we're saying is I want the table name that's created in the database to be called readings. And then we've got a number of columns here. So we've got our ID first, and that is a primary key. So that'll be what we use to identify any data within this database as unique. And we've got a unique flag there as well. Next, we've got the host name. So this will just be what the actual system name is of the device we're running on. In this case, we've got it called Pi3 server. So that will be what the entry is. And we'll get that later on. Then we've got 4 columns, one for the temperature, the pressure, the humidity, and the altitude. And then lastly, we've got another column called created, and that's just a timestamp to say when it was inserted into the table. And then the last part here, this is just a way to represent what the actual object name is. So instead of just having an object name come through when we actually query it, if we ever do query it, so we just want to get a descriptor of what it is, it'll actually say the ID and the date it was created instead of something like 0x123AB147, etc. So it's just something that's a little bit more human readable. So I'm just going to save that file and I'll close that down. And now I'm just going to open the crud.py file. I'm just going to paste some code into that. So what this code will do is it'll take a couple of imports from our custom modules along with the OS library. So in this code, there's a single function called addReading, which will take a dictionary that contains the readings from the sensor and then write them to the database. It'll also get the hostname to use for the hostname column by just using os.uname. So I'll save that file, and that's the database module completed. So we can collapse that down. So moving on to the env file because I need to make a change in there. So I need to go back into modules, env, and then I want to open the .env file. Now the changes I want to make is I don't want anything going out to the console. So I'm just going to change that to false. And then I've disconnected the LCD screen. So I'm going to set that to false as well. I'm going to save that file, close that. And now I need to make some changes to main.py. Oh, that file can be deleted. I don't know why it's there. So open main.py. So there's a few changes that need to be made in here. Luckily, they're not too drastic. So the first one I want to do is I want to take sleep part out. So I'm just going to scroll down and remove that. Okay, so let's start with the imports that are required for this. So I'm just importing the database module along with the engine and CRUD that we need. And scroll down to right here. And what this will do is it'll set up the database for us. If it can't find the file, it'll create it, and then it'll create the table if the table's not present as well. Let's go down a little bit further, and then just below this, you can put this pretty much anywhere below these sections, but I'll just put it here for now. So that's just going to get the readings from the sensor. And the next thing I want to do is then call the add readings function. I need to remove that because that's pretty much the same. I need to take that out of the while loop as well. So delete that while loop and then indent those a little bit. Just check and see if I missed anything off. Okay, that's it for that file. I'm just going to save that, close that down. So let's give that a try and see what happens. So before I run that, if it runs successfully, you should see a file show up on the right side saying database.db. And if this goes through, you'll see nothing in the console other than another command prompt. Okay, just got a quick refresh. It didn't update itself. There we go. Okay, so let's have a look at that database file and see if it's actually written the entry correctly. So just run SQLite database.db. Okay, so if I done this already a couple of times, so I'll just run this. So this should return back with one single entry into this database. Perfect. So that worked a treat. So I'm just going to exit out of SQLite. Clear the screen. So with that working, what I can now do is set this to run at a particular interval each day. You can set that to whatever you want, but in my case, I'm going to set it to run every 5 minutes. And to do that, I'm just going to use a cron job. And to do that, I just run cron tab -e. So this will open up my list of cron jobs. And if I scroll down to the bottom, I've already got one in place for something else that I was already testing out. So if I just change that to project, and then what that will do is every 5 minutes, go into that folder, run this virtual environments version of Python 3, main.py, and then it'll write the entries to the database, close the program, and then the next 5 minutes later, it'll run it again. Now, when I say 5 minutes, it's not like if I start this at 1 minute past 3, for example, the next poll will be 6 minutes past 3. It's actually first poll will be 3, or the first 5 minute interval past an hour that the next schedule is set to. So if I set it at 3:01 again, then it will run at 3:05, then 3:10, 3:15, etc., etc. I just need to save that, so I'll just do Control X and then yes, enter. And that should basically be it. So I'll leave that for a little bit and see what comes back. Okay, so I've left it for about 15 minutes. So let's have a look at it. So I'll run SQLite 3 again. And let's have a look at that table. Excellent. We've got 3 results in there. So one was the original one. And then we've got 2 additional ones, which all ran at 5-minute intervals. So, yep, that's working fine. So that completes that side of the project. So what I'm now going to do is I'm going to switch over to making the web server to present this data in a little bit more of a presentable format. With the program for the data collection now completed, let's move on to creating a simple web server to view the last 10 readings and provide a way to download all the readings to a CSV file. To begin with, I'm going to create a new folder in here called web server. Before I go any further, I'm just going to deactivate that virtual environment. So now within that folder, I'm going to create a bunch of other folders. First, a folder called modules. and then another folder in there called database. Next, I'm going to create a folder called static, and then within that folder, I'm going to create one additional folder called CSS, and then another folder at the web server level called templates, and then I'll do it for the folders for this particular web server. Okay, so I'm just create another file in here. I'm going to call that requirements.txt. We've got some packages we need to install for this web server. So this is the list of packages I'm installing. So most of it's pretty straightforward and some of it's new. So we've got SQLAlchemy again. We've got Flask, which is the actual web server itself. Ginger2, which is used for our HTML templates. Pandas, which we'll be using to make some interactions with the database a little simpler. NumPy is just a requirement of pandas. PyTZ again is a requirement of pandas, which is just used for time zones, but we're not going to be using that. And then pretty much everything else is just a dependency for something else. So I'm just going to close that file, and I'm going to go into web server folder, and I'm going to create a new virtual environment in here. Now this won't impact the other virtual environment that was created for the data collector project, as these two will be completely separate. So if I activate one, it doesn't activate the other and cause conflicts. Okay, so I'll just activate that, clear that out, and then I just want to install those requirements. Okay, I'm just going to check to make sure I installed Ginger 2 properly because I had a network timeout there for some reason. Yep, it's installed. That's fine. Okay, so just going to refresh that. There we go. That's better. So I'm just going to go back into the database folder and I'm going to create a bunch of files. Again, pretty much the same as the last time. So it's going to be init.py, engine.py, and models.py. Now we don't need the crud.py file this time because the operations we're going to be doing is going to be part of the code that we're going to be writing in main.py instead this time around. So doing a little bit differently. Let me just change the interpreter actually. That one will do. So close init.py down. I'm going to start with engine, and pretty much this code is basically going to be the same as what I used before, with just I think one slightly modified line. Yeah, so I'm just making an additional session connection here. And that's it for that file. So everything else is basically the same. Save that, close it. And then models, that is exactly the same. So there's no change here. Now I could have reused this from the other models and engine, but I've decided to separate them up for the time being because you might want to go and separate it and put it somewhere else and have its own dedicated database or use a completely different database altogether like Postgres or MySQL. So I'll close that. And then I'm going to move over to the CSS folder and I'm going to create a new file. What do I call it? Style.css. Now, I'm not going to spend too much time going over this. It's a CSS file with a bunch of styles in it, so it's not really worth going over in any depth. Oops, that's the wrong file extension. Try again. That's better. If you want to look at it, you can do. But that's basically all there is to it. That's just a little bit of custom CSS. There's a lot more that would be taken from Bootstrap in the templates. Speaking of which, I'm going to create two files in here. First one called base.html and then another one called index.html. What we've got in here is pretty much just a basic HTML document. There's some Bootstrap, so that's just going to give us more CSS styling. That's going to be the majority of it. A bit of jQuery, and then pretty much the standard layer that we're going to go with. And then this particular part here is part of the Ginger 2 templating, which allows us to create a block, which in this case we call content, so that I can insert whatever's in index.html. And I'll go over that in a second. And then that pretty much is the end of the HTML for that particular document. So I'll save that. I'll paste in the index.html content. So scroll to the top, it'll call extends base.html. So it'll just take all the headers and whatnot that's already in there. And then just when it finds the block called content, this is what will be inserted, which is basically a simple table. And then in here, we've got a for loop using Ginger 2 to basically create the individual rows for each entry in the database, which will be limited to 10 for this particular page. If I did them all, be like 30-odd thousand lines potentially, or even more. So with it, just end the for loop, we end the block, and then that's basically the end of that. Save that file and close it. The last thing I need to do is create a file called main.py, and now we can start building our web server. So I'm just going to take all the code and just paste it in, and then I'm just going to go over it bit by bit. So the first thing we've got is our imports as usual. So we've got Flask, which will import the Flask main app, render template, and make response. We'll get to what those do later on. And then we've seen these before. These are imports from our database module. And then I want to install pandas as PD. So that's just a short form way of just saying pandas. So pandas just allows us to interact with the database a little bit easier through SQLAlchemy, and then take the results and then do whatever we want with them. Makes it a lot easier than doing it with other libraries. So what I now need to do is set up a new application, which will use Flask. And the name of the application that Flask uses will be whatever the name of the file is. So if I remember correctly, it's called main. And then what we've got is two simple routes. So a route basically is just an entry point into the web server for a web page. So we've got two simple routes. The first one is just home. That's basically just going to bring us a template file back, which will be index.html, and present out 10 results to the page along with the rest of the formatting, etc., to present our standard home page, as it were. So the first thing it'll do is it'll create a new variable called results, and what that will have is the last 10 entries in the database table for reading, and that will then be passed into the index.html template further down using readings as a result, and that will then just present a table in index.html with those entries in. So we've got a second route, which is called download-all, and what this will do is allow us to download all of the readings from the database into a CSV file. I'm just going to make a slight change because that's actually no longer needed. I left that in by accident, and that's just a comment basically to let us know that what we're doing here. So df is a new variable, it's short form for data frame, and we're going to use pandas to read a SQL query, which in this case is SQL query reading.statement. So what this part will do is, because SQLAlchemy uses standard SQL underneath, but does it in a more Pythonic friendly way, you can actually get the SQL statement from that particular SQLAlchemy call. And what it will basically do is return what I've put down here, which is select star from readings. That's effectively what that does. Now, if I didn't do that, that wouldn't work, because this particular pandas function here doesn't work with raw SQLAlchemy. You have to basically send it the SQL statement. So that's what this does. That's the connection we're going to use. And the index column is going to be the ID column. If I didn't put that in there, then it would just add another index column, which would be completely irrelevant to what we need to do. So what we're now going to do is build up a response. And what this does is allows us to just download the file. So the first thing I want to do is make the response, which will be calling that data frame up here and converting that to a CSV file. And then these two lines here just indicate what that file is. I want it as an attachment, and it's going to be called all-data.csv. And then the content type is going to be CSV, and then it'll just return the response. So when I click the download button, instead of it just wanting me to save it somewhere on the web server, it'll actually just save it through the browser to a local file system on my computer. So I'm just going to save that, close that down, and that should be all the files we need to modify. So what I'm now going to do is I'm actually going to run the web server and hope it works. And to do that, I just run flask-app main, which is the name of the app, and then run. Now, if I didn't put this here, what it would do is it would just run on localhost, and I won't be able to access it from another browser. But if I tack on --host equals 0.0.0.0, then what it will do is it'll just run on any interface. Now, that's not recommended, but for the sake of just a demo, it's perfectly fine. And we can see that's running. Close that down. Now, you can see it's running on both localhost and the IP address of the Raspberry Pi. So I could just hold down Command and then just click that to open it up in a new browser. And there we go. So you can see we've got the readings here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 there. We have a home button and we have a download all button. There's also a little bit of responsiveness on this. So if I shrink that down so it looks like it's working on a mobile, it'll collapse those menus down. Completely irrelevant for this particular exercise, but it's there if it's needed. And then close that down. And if I just click download all, you can see it's downloading the file. If I click on it, we can see the 10 entries from the database. With the web server now done, that concludes the project. I hope you found it useful. I had a lot of fun making it and learned a lot along the way. Again, if you want a copy of the code, there's a link to the GitHub repository in the description. I do have a bunch of other projects planned for 2025 and beyond, so keep an eye out for those. Thanks for watching. If you liked the video, please like and subscribe, and I'll see you in the next video.